This video is going to cover Rolle's theorem and the mean value theorem. So let's start with Rolle's theorem. What this describes is that if f is continuous on the closed interval ab, and it's also differentiable on the open interval ab, and we're really just making this distinction on closed versus open because you can't be differentiable at the endpoint, so that's why it's got parentheses rather than the brackets. So we're continuous, but we're differentiable on this interval. And then f of a equals f of b. So that means they have the same y value. So if this is true, then there is some number c such that f prime of c equals 0. So what this means is that the derivative equals 0. And we know from previous lessons that when the derivative equals 0, that's usually at a minimum or a maximum. So I like to think of this theorem called Rolle's theorem, that if you have 2 points, A and B, so that they have the same y value, as we can see on this graph, at some point between there, it's going to roll over. So it's either going to roll like a maximum or it could roll like a minimum. And really, if we think about this, it's kind of intuitive that if I have 2 points that have the same y value, and I know that between those 2 points, my function is continuous and differentiable, then at some point it's got to turn around to get from there to there, either going below or going above. And it could happen more than one time, right? So it could be like a sine function, and we have two max, or like one max and one min. That could happen as well, but there has to be some point where it does this rollover. And so the c value in this case is going to be the x value, where the derivative is 0. All right, so when we do these types of problems, we're going to have to prove 3 pieces. Number 1 is that our function is continuous. Number 2 is that it's differentiable. And then number 3 is that the two y values of the endpoints are the same. And then therefore, the derivative at some value c is going to be equal to 0. So let's see this in action. So in question number 1 here, we're trying to verify that Rolle's theorem is going to be true. So the first thing that we want to do is prove that it's continuous. Now, because we're looking at a polynomial, a quartic here, x to the 4th, we know that f of x is continuous. So we can just jump right in and say, okay, totally continuous. Step 2 is going to be say that it's differentiable. Again, because it's a polynomial, we know that f of x is differentiable. Every polynomial is going to be continuous and differentiable on all x values. The domain is negative infinity to positive infinity. So now step 3, let's actually check that the endpoints have the same y value. So we need to find f of negative 2 and f of positive 2. So let's plug that in. All right, so for negative 2, we're going to get 16 minus 2 times 4 is 8, so that's going to be 8. And then here we'll get 16 minus 8 again. And so now we have shown we are continuous, we are differentiable, and the endpoints have the same y value. And I just want to clarify that here we're continuous on the closed interval, but we're differentiable on the open interval, again, just because you're not going to be differentiable at endpoints. So because we've proven that Rolle's theorem applies, we're now going to actually use it. So we're going to take the original function here and find the derivative. So that's going to be 4x cubed minus 4x. And so if Rolle's theorem is true, which we've said it should work, then that means sum f prime of c equals 0. So that tells us that the derivative, 4x cubed minus 4x, must equal 0 for somewhere between negative 2 and 2. So we can factor this, and we can keep factoring this to be x minus 1 and x plus 1, that difference of 2 squares. And so then we can set each of our factors equal to 0 and solve. So x equals 0, 1, and negative 1. But we want to check which of these are actually in that interval, because that's actually a really important piece here, right? So if our interval is negative 2 to 2, then actually all 3 work. So we've got 3 answers here. They're all on our interval. All right, I want you to pause the video for a second, try number 2, and then check your answer. Okay, problem number 2. All right, so our first 2 steps are good. we are continuous, we're differentiable because this is a polynomial, then we want to check that f of 0 and f of 2 need to be the same y value. All right, so I got 5 for both of these, which is good. So now let's take a look at the derivative. So f prime of x is going to be 3x squared minus 6x plus 2. We need some f prime of c to be equal to 0. So we're going to set that derivative equal to 0 and solve. All right, so that means we need to factor this. So this looks like it's going to factor to be, not factorable. Okay, plan B. If it's not factorable, we're going to go straight into the quadratic formula. So x equals negative b plus or minus the square root b squared minus 4ac all over 2a. And so we're going to simplify this, and those should be our values. So I'm getting 6 plus or minus 2 root 3 over 6, and then that can simplify everything by 2's because we can do our little pizza slice there, everything by 2, so 3 plus or minus root 3 over 3. And we want to double check that that's all on our interval. That's kind of hard to tell, but if I have 3 plus 1-ish divided by 3, that's going to be a pretty small number, and 3 minus 1-ish divided by 3 will also be a small number. So it should be between our 0 and 2, which is important. All right, this last problem on Rolle's theorem tells us let f of x equal this, show that f of 0 equals f of 2. Okay, so we've got to do that, but that there is not a number c in this interval such that the derivative equals 0. And why does this not contradict Rolle's theorem? So let's start by doing the part that they tell us explicitly to do, which is to show that f of 0 equals f of 2. So f of 0, we're going to plug in 0. We get negative 1 to the negative 2. And that's really like saying 1 over negative 1 squared. That's just going to be 1. If we do f of 2, we also get 1. Okay, so f of 0 equals f of 2. Great. Let's now do the derivative, because Rolle's theorem says, we need the derivative. So f prime of x, we're going to have to use the chain rule here, but it's not super duper terrible because the derivative of this inside piece is just going to be 1. So we don't really even have to multiply by that. So for Rolle's theorem, we want to check that it can equal 0. So we can go ahead and divide both sides by negative 2. And then really this x minus 1 to the negative 3, that is saying 1 over x minus 1 cubed. And if we multiply both sides by the x minus 1 cubed, we get 0 equals 1, which no, it absolutely does not. So this is now saying the part where there is no c, f prime of c never equals 0 on this interval or anywhere, right? So that's a problem, but it's telling us this is not contradicting Rolle's theorem. So why does it not contradict Rolle's theorem? Well, let's take a look at the function itself. So f of x can be rewritten using our knowledge of negative exponents as x minus 1 squared. Is this continuous and differentiable on the interval 0 to 2? Well, since we have a fraction, if we were to plug in x equals 1 here, we'd get 0 in the denominator, which is undefined, which means it's not going to be differentiable. So no, it's also not going to be continuous, right? So no, this is not actually contradicting because it's not continuous. So f of x, not continuous. And so this would be our statement of why it does not contradict Rolle's theorem.